Hello everyone, today I will be talking about how to set up an ANSYS simulation of supersonic flow over a nose cone. I will be going specifically over the design of the part as well as the meshing. So to begin with your part, I will be setting it up as an axisymmetric case. So I have just constructed this simple geometry in SolidWorks, and I have made the enclosure or the fluid flow region about 10 times the reference length in the vertical and the upwards region, and about 5 times the reference length in the side region. So the reason I like to use SolidWorks is just because it's very user-friendly. And you will notice that when you get to Design Modeler, it's not the most user-friendly software out there. So use whatever CAD software you're comfortable with before importing the geometries. So to begin with, just drag your ANSYS Fluent simulation case in here, name it whatever you want. I just named it 2.0. And you go to import, then when you want to import geometries in ANSYS Fluent, I found that the best file extensions to use are either IGS or XT. So if you want to do that, you can go to your SolidWorks file and then save as, and then you could save it as IGS in here. Or if that doesn't work, you could also save it as a .xt file as well. So we can go ahead and import our geometry, so we can browse for it, and then yep, it is right here. So the next thing we want to do is we want to edit our geometry to just make it easier to mesh. So we edit the geometry in the Design Modeler. And then as you can see here, we have our import code. So we just have to generate it in here. And here we have our part that we imported from SolidWorks. So when you are meshing a part, it is very important that you split up the regions into smaller, easier to mesh regions. So in this case, I'll show you how to do that. So we can go to our XY plane and then create a new sketch. And on that new sketch, I'm just going to create just a small box that encloses the nose cone. Go ahead and that. And again, this is very arbitrarily chosen. Just by experience, you can go back and forth and change the region to just make it easier to mesh. So I'll just go ahead and give this the horizontal and vertical dimensions. From here to here, that's going to be 0.5 meters. And also from here to here, that's about 0.5 meters as well. So this is the region that I said I want to just have it more refined. So I can go ahead and go to concept, and then lines from sketches, select the sketch I just created the lines in, click apply, and then click generate. So in order to split up the body, you go to tools and then face split. You select your target face and then you select your tool geometries. So in order to select the lines, you can just change the selection filter to be edges. So we can go ahead and select these 2 edges in here. And then we finally click generate. Just to double check that you have 2 separate faces, you can just change the selection filter to be faces. And as you can see here, I can select 2 different faces. So finally, the last step is to suppress your line body that you created earlier. So again, this is very arbitrarily chosen. You can go back and forth between the meshing and the part to see which one suits the best for the geometry you're analyzing. All right, we can go ahead and close our design modeler window, and we can start meshing the part. Alrighty. So I will be going over how I set up most of my simulations. I like to use this method because it's kind of like the fastest way possible and the most reliable way I found, as well as the easiest. So in here you can kind of select your element size and to be whichever one you choose. So you can just leave it as the default, because for the most part in the outer or the free stream region, you don't need to have a very refined mesh, so you can just leave the element size to be default. However, we want to have a very fine mesh in our selected box, so we can go ahead and choose the sizing and then select the face in here. We can set it to be a smaller element size, so something like 0.5 meters. And it is also very important that you refine the mesh near the wall or near the region you are interested in. So for that reason, I'm going to use inflation. All right. And inflation allows you to kind of control the boundary layer for external flow problems. This option will not work if you are using a face meshing option. So just be aware of that. If you're trying to use both options, you can't really do that. All right, so we can select our region here, and we select our boundary to be our area of interest or our wall of interest. All right. So we selected our edge, and then we can go ahead and select the total thickness of, or we can either select the total thickness. So if you know what the boundary layer is gonna look like, you can select the total thickness, and then you said, for example, if it was something like 0.01 meters, you select that to be your maximum thickness, and then you select the number of layers across that boundary layer. However, for this method of analysis I'm using, I'm not really going to be concerned about getting the right number of elements across the boundary layer. I'm just going to be concerned about making sure that the mesh actually translates the geometry accurately. So I'll just go ahead and select the first layer thickness, and I'm just going to tell it to have 10 layers. And for the first layer height, I'm just going to tell it to be 0.01. So it is very important that you refine the mesh near your area of interest, just because when you import the geometry in the ANSYS Fluent, it forgets what the actual geometry looks like and just remembers what the mesh looks like. So just be aware of that. All right. So another option we could use to also refine the mesh is we could use a sphere of influence. So let's select this boundary, and then we can select the type of sizing to be sphere of influence. And the sphere center, we just want it to be in this point, which happens to be the global coordinate system or just the center axis. So we want to have the element size to be the first layer thickness as we have defined here. So that's going to be 0.01. and we want the radius to be 10 times that. So we can just set up that to be 0.1. Another thing that's also very important is you have to select the number of elements across your boundary. So as we have said, we want to have an element size in the first layer height to be 0.01. So we're just gonna have the element size across this boundary to be 0.01 as well. All right. All right, awesome. Now we can see we have very nice square mesh around the boundary. Now, the reason I chose a sphere of influence is because sometimes when you set up the inflation option without refining the region in here, you get a very low quality mesh in this region. And I'll show you what I mean if I just suppress this right here and regenerate the mesh. So you can kind of see here that you get a very large size mesh compared to the mesh in the boundary layer in here. So I'll just go ahead and unsuppress this option and regenerate my mesh. All right. So two metrics you want to watch out for when you are running supersonic flow simulations are the aspect ratio as well as the skewness. So to check your aspect ratio, just go to mesh. Then from the drop-down menu, select aspect ratio. And in here, the ANSYS Fluent guide recommends that you keep it below 35. However, when it comes to the boundary layer region, try to keep it less than 5. So in here, you can see that using this option, I was able to get something very close to 1, which is very good. And another metric you want to also watch out for is the element skewness. So you want to keep this below 0.98. If you have anything higher than 0.98, ANSYS Fluent will tell you that you may have instabilities in the simulation. But you can see here that our element, the maximum skewness was 0.8. So we should be good. All right. So the last thing to do in regards to meshing is to name your walls or your boundaries. So we can go ahead and select, make sure that the edge selection option is selected. So right click on this region and then we say create name selection. We will name it inlet. Again, click on this region, outlet, side, click this region, back, select this region, and then name it the axis. And this is going to be our nose. So it's very important that you select, that you name your boundary conditions or you name your walls, just because when you import this to Fluent, you can, you know already which, the name of each wall or the name of each edge in the case of 2D simulations. All right, so we should be all set to run this in Fluent. So after you're done with the meshing, you just right click on the mesh and then update it. Right, it did not give us any errors, so we should be good. So some of the other options you can explore when you're meshing the part and controlling your meshing is going to be shown in here. All right, so most of the time you want to have a very structured mesh, and that's why it's important to use your face meshing option. So in order to get that right, you can see here that I've splitted this geometry into multiple regions. And so if I show you what the mesh looks like, you can see here that it's very, very structured. And this is also like very important if you're running supersonic flows because your results are heavily dependent on your mesh and mesh quality. So what I did in here is I just made sure that my face meshing option was selected. And you can see here that this does not always work. So for example, in this region, it wasn't able to create a face meshing option, but it was able to create a face mesh for all the other regions. So I believe the way that the face meshing option works is that it just makes sure that all your elements are square size. In fact, you can actually select whether it's going to be quadrilaterals or triangles. So the way I have done this is I have selected and kind of chose the face sizing as well as the different edge sizing for each different region. So I just want, so for this region it was about 0.025 thick. So I just wanted to have two elements across this region here. So I just made the element size half the thickness. So it's going to be 0.025 divided by 2, which is 0.0125. And also some of the other very useful options you could use is you could use an edge sizing with a bias. So the way this works is if you look here, it makes the elements in here smaller compared to the elements on the top. Let me show this in one of the other options I used. Yeah. So if you can see here, this is way smaller than the elements on the top. And the way that you do this is, so if you're looking at this region, for example, so you select your edge, and then you select your element size, and then you go to bias, and you select the bias type. So by default, it is set to no bias. So you just have to change that and just make sure that it is in the right direction. So the reason I'm using this option is just to make the transition from the coarse mesh in here to the fine mesh just kind of smoother, and that will help the ANSYS Fluent software in meshing the part. So yeah. Yeah, you can see here that these elements are much more coarse when compared to these elements in here. Yeah, like I said, you can kind of experience with different options to see which one suits your geometry the best. The reason I like to use the other method of inflation is just because most of the time I have very complex curves, and the inflation option is kind of, like I said, the easiest and just gives you the best results, because most of the time you're not really concerned about the upstream region, and you're more concerned about the near wall region. All right, we'll just go ahead and close that. Thank you for watching. If you have any questions, please leave them in the comments below, and I will do my best to answer them. Thank you.